Hello everyone, hope you all are safe. Let us continue our discussion on fifth module of gas turbine technology course. So the topic is evolution of gas turbine testing as well as the hierarchy of that particular testing. So basically when we say gas turbine testing there are different methods. So we'll understand one by one. So the first one is ground testing. So ground testing in the sense here the ambience what we are going to create for that engine testing will be of the sea level condition. So that's why the word ground testing. And among this ground testing, there are two different types. The one is indoor ground testing, second one is outdoor ground testing. So in future videos, possibly I'll show you the different setup or the schematic diagram of this indoor and outdoor ground testing. And basically, we have already discussed this one in our regular classroom class. So that is about ground testing. Whereas the second one is altitude testing. Now in this altitude testing, we are going to recreate the ambience of certain altitude where the density, temperature and pressure is varied accordingly. So for that particular altitude, what will be the behavior of an engine that will be tested, and also at that particular altitude it will be either cruising or climbing or descending. For that particular velocity as well, what will be the engine behavior that will be tested. Now all these ground tests as well as this altitude test are majorly focused on fine tuning the throttling of a fuel and also the behavior of each component of gas turbine engine. So these are the two types. One is ground testing, in that there are indoor and outdoor. Second one is altitude testing, which is done again at ground level, but ambience is created of certain altitude. Third one is flying test bed, where the engine what is designed is made to fly with another aircraft which can carry that particular engine, and it will be tested for different flight envelope. For example, let us consider an aircraft which is driven by four engines, where three engines are its regular engines, whereas the fourth one is the one which has to be tested. Now, once the aircraft starts flying at certain velocity for its complete flight envelope, the fourth engine is tested on regular basis for all the flight conditions. So this particular testing is nothing but flying test bed. Now please remember, in the flying test bed, it is not tested only at ground, it is tested for the complete flight envelope for which it is designed for. Next, there is one more test called preliminary flight rating test. This is an evolution of altitude testing. Like preliminary flight and the rating what we are going to give for that particular efficiencies of those particular components are tested in PFRT, that is preliminary flight rating test, which is the fourth type. Then we have one more test, that is model qualification test, where a particular component is modeled, means it is scaled down, and then it is tested for certain endurance or certain flight hours. Basically, it is 150-hour endurance test where the model is tested, and based on its performance, whether it is qualified or disqualified is finally decided. Then we have one more test called ground testing in actual application. That is, experimental flight testing will be done. There will be few sensors used on that, and then experimentally these flight testings are done. Where in ground testing, whatever testing they are going to do, that is basically based on the temperature, pressure of each components. Whereas in ground testing in actual application means each sub components are also tested. Now after these testing, there is a certification whether the component is certified for certain flight or for certain Mach number. So these kind of certifications are given. Apart from that, which type of fuel can be used, the alternative fuel can be used, and also can we replace this engine from one aircraft to another aircraft, that is like exchanging the engines, is it possible? For all these things the certifications are required. Apart from that, if you want to replace any of the components or sub components, then again those have to be certified. So certification tests are also need to be done. Apart from this, now when we say production of these engine components, now whether it has to go for a batch production or it has to go for a mass production or it has to go for a specific production. So all these are again decided based on what is the certification it is going to get. Apart from that, the production testing, whether it is feasible to go for that kind of production, even that has been tested. Now, after all this, there is one more test called acceptance test. So once the production is done, what is the level of acceptance we are going to get? Or by using that particular production method, what is the acceptance we are going to get? So this is an acceptance testing. So basically what we discussed from the beginning is initially there is a ground test where there are again two types. Then there is an altitude test, means again we are going to set up the same altitude condition at ground condition itself. Then flying test bed where the engine is carried with an aircraft and tested for different flight envelope. Then PFRT, that is rating test, will be done for individual components. Then model qualification test, which depends on endurance or around 150 hours of endurance test. Then there is a ground test in application level or actual application level that is done. Then there is a certification test, then there is a production test, and finally the acceptance test. So these are the different evolution, but as per our syllabus we will be restricting ourselves with only the first three testing, that is ground testing, altitude testing, and flying test bed. So these are the major three testing methods which we need to focus as per our syllabus. I hope this is clear. So if you have any doubt, please communicate back with me so I can clear your doubts. Thank you.